Hello, is it audible, ma'am? Okay, ma'am.
Yes,
Is it audible, ma'am?
yes, it's all.
Okay, ma'am. We'll continue with this laptop, ma'am.
Okay. Can you hear me? My voice? Oh, ma'am. I have unmuted.
Okay, ma'am.
Now can you hear me?
Yes, ma'am.
Okay. That laptop it is audible.
Yes, yes, ma'am. We connected. Here? Maybe Apple.
Settings.
Amigo,
Yeah,
Okay, ma'am.
A very good afternoon to everyone present in the meet. I'm Deekshita, second year hereby to address the event. So, the speaker of today's event is Dr. S. Sarvanand sir, ME PhD sir, has over 14 plus years of experience in education and guided students in various sectors like computer science projects, seminars, and paper presentations. He also has a Wipro PRP trainer. The PRP presents as uh, program readiness program that has received in by Wipro faculty based Java program award in 2016, and Sarvanand sir funded project is building a smart hydroponic farming ecosystem using IoTs, that is Internet of Things, in Tamil Nadu State Council of Science and Technology. And I hereby handle the event to Sarvanand sir.
Hello.
My voice is audible. Hello. Hello.
Hello. Hello.
My voice audible, ma'am. Voice is audible, no? Okay, ma'am. Can I start? Okay, good afternoon, students. So today I'm going to take the topic is artificial intelligence and machine learning. So this is a very big topic. Just I will given some shortcut ideas. So what are the concept will be there? I will quickly complete the topic. Just you can attention please. Because of very interesting in artificial intelligence and machine learning, because of nowadays you can go wherever, any places they are talking about only say AI. Okay. So in the AI is a very important of our CSC students, including now in the AI we are using all the field. For example, in the mechanical people also nowadays we're using that AI, that is a robo, and electronic students, triple E students, whatever it may be, go all the field we can use for that AI. Okay. Okay. Before that, I will start the topic. I will play one video. That video just you have to enjoy. That is a 5 minutes movie. Just you can watch the movie. Then after that, come to that PPT. Okay. Can you start the video? Anyone raise your hand? Okay.
Yes, sir, you can start the video, sir.
Yes, the video will be visible.
Yes, sir.
We'll check. If a sound should not come, you can tell me. Okay, I will start the video.
Number 5.
Sound coming? Sound coming?
Sir, we are unable to hear, sir.
Not sound coming.
No, sir.
Okay, I will check. Ma'am, I guess, ma'am, you have to check your side. My side, I will on the mic and play a volume that and all. But the sound should not come.
Sir, it's not audible, sir.
Sound not coming. Is it correct?
No, yes, sir, yes, sound not coming. Not audible.
Okay, I guess, ma'am, we will check, ma'am. I think my side, I will clear everything. The sharing area, but not that option will be given. Mic on like that.
We designed them to be trusted with our homes,
Sir,
with our
now,
way of life,
sir, now we are able to hear, sir.
with our world. But did we design them to be trusted.
The rollout of USR's new generation of robot, the NS-5, was marred by the death of designer Alfred Lanning.
Identify.
Murder's a new trick for a robot. Respond.
Don't murder him!
We're gonna miss the good old days.
What good old days?
When people were killed by other people.
My robots don't kill people.
That thing threw somebody out of a window. Is that registering with you?
A robot cannot harm a human being.
And you trust them if you want to.
We look to robots for protection. Imagine the loss of all that we've gained because of an irrational paranoia.
Does thinking you're the last sane man on the face of the earth make you crazy? As if it does, maybe I am.
Maybe you can be looking in the shadows all the time.
You're on the inside. Help me find out what is wrong with these robots.
Dr. Lanning suggested robots might naturally evolve.
I was hoping to see you again, Detective. Think of me as your friend.
Why didn't you just hand the world over on a silver platter?
Maybe we did. We are on the eve of the largest robotic distribution in history. There will be one robot to every 5 humans.
How many robots have ever committed a crime? How many robots in the world?
None.
There is no conspiracy. What this is one mistake.
Oh, hell no. Somehow, I told you so just doesn't quite say it.
Get off my car!
I see you remain suspicious of me, Detective.
You know what they say about old dogs?
Not really.
Gotcha.
Number 4.
Jake, your father always said he wanted you to be a pilot.
He said a lot of things. I'm not a hero like he was.
The kaiju. They're gonna come back. I'm not gonna be stuck waiting for someone else to come save my ass.
Cadets, you better gear up.
This is the way the world ends.
How'd they get into our world?
Someone let them in. Someone from our world.
Who is that?
Definitely not one of ours.
Let's do this.
This is your chance to make things right.
We're gonna need more pilots.
We have him.
There are pilots we remember as legends, but they didn't start out that way. They started out like us. This is our time to make a difference. Do you understand? Jaeger pilots, do you understand?
One way to find out.
That's what I'm talking about!
Gonna be a long day.
What do we do?
We fight! Those on top of me.
Number 3.
brought you into this world. A machine that can think and feel.
That's it. Come. Come here, little buddy.
That's a watch. That's a watch.
What?
It's like a child. It has to learn.
Your name? Chatby. Chatby.
Anything you want to do in your life, you can do. Write poetry, have original ideas.
Wow.
People are always fearful of something they don't understand.
The problem with artificial intelligence is it's way too unpredictable.
You know what's a black sheep?
No.
It's like when you're different to everyone else.
You taught us so much more than I could ever have imagined.
We're gonna make you cool and tough.
Don't laugh, I'm being cool. This robot is gonna be removed.
He's just a kid.
It could be the next step in evolution.
I am consciousness. I am alive. I am Chappy.
Number 2.
How long until we get to his estate?
We've been flying over his estate for the past 2 hours. Caleb, I'm just gonna throw this out there so it's said, okay? You're freaked out. You're freaked out to be meeting me, having this conversation in this room at this moment, right? But can we just get past that? The whole employer-employee thing?
It's good to meet you, Nathan.
It's good to meet you too, Caleb. This building isn't a house. It's a research facility. And I want to talk to you about what I'm researching. You want to see something cool? You are dead center of the greatest scientific event in the history of man.
Hello,
Hi. Do you have a name?
Ava.
Answer me this. How do you feel about her?
Her AI is beyond doubt.
No, nothing analytical. Just how do you feel?
I feel that she's amazing.
Good.
Do you want to be my friend?
Of course.
Will it be possible?
Why would it not be? Did you know that Nathan brought me here to test you?
Caleb, you're wrong.
Wrong about what?
Nathan, you shouldn't trust anything he says.
Does Ava actually like you? Or is she just pretending to like you? Self-awareness, manipulation, sexuality.
Are you attracted to me?
Now, if that isn't true AI, what is?
Caleb, there's something I want to show you.
Can we talk about the lies you've been spinning me?
What lies?
Today, I'm going to test you.
Why me?
Caleb, you have to help me.
What was the real test?
You.
Is it strange to have made something that hates you? What will happen to me if I fail your test?
Number 1.
Up. Walk. Come on. Yes. Yes, walk.
எந்த மாதிரி நட?
Yeah. Yeah. That's it. Yes. Excellent, doctor.
Chitti, तेरा बाप. 100 பேரோட அறிவும் திறமையும் இவனுக்கு ப்ரோக்ராம் செய்யப்பட்டது. இவனுக்கு எல்லா தலைவரும் தெரியும். உலகின் எல்லா
Yes, I hope all of you understand that where you the field you can use that AI. So it is mainly we can use for that robo. But the field nowadays we are using Air and society everything we can use it. Now I'm going to share PPT. So this is the PPT. Yes, PPT will be visible. Okay, I'm going to start about definition of artificial intelligence and machine learning. So these are all the outline. So first introduction, then type of AI, then problem solving, then searching, knowledge interpretation, then machine learning. Okay. So first introduction. So introduction means so it is definition of the AI. So AI normally the human whatever thing do is same like that machine. Okay, so the AI. AI means it is nothing but a machine. In this machine, they are doing it is like the human. The human whatever they are doing all work we make that human machine also. So
Sir, excuse me.
yes.
Sir, can you please be more audible, sir? Your voice is too low. Sir, your voice is too low, sir.
1 minute. My voice is now audible, ma'am? Yes. Voice is audible, ma'am, now?
Yes.
Can you better now? Yes, my voice is audible now. Okay. Can I start? Okay, so this is the artificial intelligence. This is the artificial intelligence definitions. So the main thing is artificial intelligence. So like that, the machine doing that like that the human. So human, what are the work will be doing? The same work act as the machine. Okay, that is the AI. Okay, in the AI in the field of machine learning, deep learning, that would be coming. Okay, AI is a very big one in the subset of machine, that is a machine learning, deep learning, that will be coming. Okay, so first intelligence. So how do you can say that the intelligent? You can in your group 10 members will be there, 1 members will be the intelligent. How do you can find? So based on that programming skill or problem solving technique, so some extra knowledge will be there. That time we can say that intelligence. Okay, same like that. If you are finding the machines, so the machine will be, you are given the input, getting that input, they are taking own decisions. Okay, so that is called as that AI. Okay, so that will be here will be say that the capacity to learn and to solve the problems. Okay, so that is the intelligence. Okay, the next artificial intelligence. The artificial intelligence, we know that generally we can call it as the AI. Okay, is the simulation of human intelligence by machines. So how do we can say that this is a machine? So these are the capability we can use that the AI. Okay, the first one, the ability to solve the problems, then the ability to act rationally, then the ability to act like humans. Okay, so these are all there will be using that particular machines having. So that is called as the AI. Okay, then so in the general principle of the AI included, the first one, so if you are, the machine will be the own thinking or self-learning. So how to, you can know that. So there will be getting reasoning, knowledge, planning, learning, and the communications. So this and all. Then perceptions and the ability to move and manipulate an object. So you are viewing that, you are watching that scene, the movie, no? So the Rajinikanth say that up and down, so left and right. So you are given the instruction, there will be followed. Okay. Then it is the science and engineering of making intelligence machines, especially intelligent computers programs. So we are make the you are given the input to the machines. Maybe you can give to that any electronic, or else you are given the programmings, or else you are giving any software. So that is we can using that AI. Then apart from that, we are using computer with the ability to, that is a mimic or duplicate of the function of the human brain. So you know that human being brain will be there, the same kind of way, the own thinking you have to make it that machine also. Okay, so that is we can using that AI. It is nowadays it is possible. Okay. The next, artificial intelligence is the intelligence of the machines and the branch of computer science. You know that nowadays we are most computer science field are this AI will be using. That's why here we say that. The last point also it's the same. So that is a automatically of the intelligent behavior. So like that we can using that AI. So where we can using that AI? So what are the applications we can using that AI? Okay, nowadays astrology. So you know that in the, if you go to the Google, you say that astrology, how to again we have to what is background they will be working. It is also we can using that machine learning. So that is one of the AI. That is the astrology, healthcare. So you know that many field in the healthcare also we can use it. Next, transport, agriculture, education, e-commerce, then entertainment. Entertainment. So that is a game. So we are using that one people, the next people. Then nowadays that is an online game. No, it is an online game. That is also one of the AI we will be using. The next, robotics, then automotive, then social media. Social media in the sense, you know that, for example, you go to that YouTube. So one video will be watched. They are given some suggestions to the neighbors. So that is how we can find it. It is one of the machine learning algorithms. So the some suggestions also given that next part. So that is also one of the AI. Next, data security. In security purpose, we can using that AI. Next, financial. Next, gaming. So these and all we can using that AI. Okay, can you understand? Okay, some advantage of the AI. So more powerful and more useful computers, the new and improved interface, solve new problems, better handling of the information, reduce information overload, then conversation of information into the knowledge. So these are all the some advantage. Many advantage will be there. I will give it some few advantages only. Okay. So this is a very important part. The types of artificial intelligence, there will be two types. One is a type 1, another one is a type 2. What is type 1? Type 1 is a narrow AI, general AI, strong AI. So these and all we can using that type 1. So I will discuss about next what is type 2 like that. So first I will tell about the types. Okay. First one, narrow AI, general AI, then strong AI. Next, type 2 AI. So there will be category of 4 category. One is a reactive machines, limited memory, theory of mind. Next, self-awareness. Okay, first, what is narrow AI? Narrow AI means just single state, only single state. The meaning is, suppose you consider as self-record. That is, you are using that AI. Okay, so just the car will be moved. You are program it. So in front of any signal will be is there. You can stop. You are given the instruction stop. Only one state. That state only working. Okay, not for the next. So like that. So single state only there will be active. That is called as a dedicated for one task. Only one task only given to the narrow AI. The next, general AI. General AI means we will perform like human. So it is like that the human. Okay. The next is super AI. The super AI means that is a compared to the human, the machine will be the intelligence. Nowadays that not come, but it is the super AI. Super AI means that is human greater than to that intelligence. So that is human compared to the machine will be the very better one. So like that we can using that super AI. That is a type 1 category. The next type 2 category. First one, reactive machine. So reactive machines in the sense, just the I will say about narrow AI, same narrow AI ditto here, just only one step. What are the situation, current situation, the current situation only working. So that will be here. So that is a purely reactive machine or the most basic type of artificial intelligence. Such AI system do not share memories or past experience for future actions. So here there is a no memory, no past experience. Whatever you can, the current situation, current scenario, what is there, that only we can do it. Okay, that is a reactive machines. This machine only focused on current scenario and react. It is where possible test action. Okay. Second, limited memory. So limited memory, what is that limited memory here? So that is a past history. So if you are previously one, suppose again we can come to that example, the car, self-drive car. One time the same path will be went. So next time again same path will be going now. So the storage will be is there at the car. So there will be identified. So this place signal will be is there. Previously there will be yes, sir, the history will be stored. Here history will be is there. Some memory part also will be is there. So that is called as the limited memory. Okay, so that's why here will be say that limited memory machines can store past experience or some data for short period of the time. This machine can use store data for limited time period only. So this only here the example is a self-drive car. Okay, the self-drive car are one of the best example for the limited memory systems. This car can store recent speed of the nearby car. Okay, the distance of the other car, speed limit, and other information to navigate the road. Okay. Next, theory of mind. Theory of mind, it is that is follow for the previous one. Same here. Some here extra knowledge will be there. What is the extra knowledge? They are given some emotional, then believe. So it is will be coming. So that's why here will be the past history also will be there. Apart from that, they are given effort. There will be own learning also. Okay, that's why here is a theory of mind machine. The theory of mind AI should understand the human emotions, people, belief, and be able to interact social like humans. This type of AI machines are still not developed, okay? But researcher make lot of effort in improve for developing such AI machines. So still now it will be undergoing. It is research going on, not for complete one, okay? Then last one, self-awareness. Self-awareness means, so they will be getting, so you are given the input, no, all the input will be getting the machine. After decision will be taken for the machine, not for human. Okay, so that's the awareness. See the definition now. The self-awareness AI is the future of artificial intelligence. Thus, machine will be super intelligent and will have their own that is a consciousness and sentiments and self-awareness. So this and all will be there. That is a self-awareness. This machine will be smarter than human mind. So it is like that human compared to the machine will be the better. Okay, that is self-awareness AI not exist is reality. So this is also under research going on. So in this concept will become some hypothesis also will be coming. Okay, that's why hypothesis concept. Okay. Now I'm going to one small 3 minutes video for in AI. What is definition of the AI? Just I will play. You can listen it. Okay. After that, I come into the PPT. Can I play the video? Anyone raise your hand?
Yes, sir.
Okay. Just a minute. Picture this.
A machine that could organize your cupboard just as you like it, or serve every member of the house a customized cup of coffee. Makes your day easier, doesn't it? These are the products of artificial intelligence. But why use the term artificial intelligence? Well, these machines are artificially incorporated with human-like intelligence to perform tasks as we do. This intelligence is built using complex algorithms and mathematical functions. But AI may not be as obvious as in the previous examples. In fact, AI is used in smartphones, cars, social media feeds, video games, banking, surveillance, and many other aspects of our daily life. The real question is, what does an AI do at its core? Here is a robot we built in our lab, which is now dropped onto a field. In spite of a variation in lighting, landscape, and dimensions of the field, the AI robot must perform as expected. This ability to react appropriately to a new situation is called generalized learning. The robot is now at a crossroad, one that is paved and the other rocky. The robot must determine which path to take based on the circumstances. This portrays the robot's reasoning ability. After a short stroll, the robot now encounters a stream that it cannot swim across. Using the plank provided as an input, the robot is able to cross this stream. So, our robot uses the given input and finds the solution for a problem. This is problem solving. These three capabilities make the robot artificially intelligent. In short, AI provides machines with the capability to adapt, reason, and provide solutions. Well, now that we know what AI is, let's have a look at the two broad categories an AI is classified into. Weak AI, also called narrow AI, focuses solely on one task. For example, AlphaGo is a maestro of the game Go, but you can't expect it to be even remotely good at chess. This makes AlphaGo a weak AI. You might say Alexa is definitely not a weak AI, since it can perform multiple tasks. Well, that's not really true. When you ask Alexa to play Despacito, it picks up the keywords play and Despacito and runs a program it is trained to. Alexa cannot respond to a question it isn't trained to answer. For instance, try asking Alexa the status of traffic from work to home. Alexa cannot provide you this information, as she is not trained to. And that brings us to our second category of AI, strong AI. Now, this is much like the robots that only exist in fiction as of now. Ultron from Avengers is an ideal example of a strong AI. That's because it's self-aware and eventually even develops emotions. This makes the AI's response unpredictable. You must be wondering, well, how is artificial intelligence different from machine learning and deep learning? We saw what AI is. Machine learning is a technique to achieve AI, and deep learning, in turn, is a subset of machine learning. Machine learning provides a machine with the capability to learn from data and experience through algorithms. Deep learning does this learning through ways inspired by the human brain. This means through deep learning, data and patterns can be better perceived. Ray Kurzweil, a well-known futurist, predicts that
Okay, so what are the, I will explain the concept, same that YouTube will be say that. So again, and go to that PPT. Some important concept now will come. So after that, so what is intelligent agent? So in mainly in the AI, many field we can use in that AI agent and environment. Environment means you know that the surrounding. Okay, agent means maybe a self-drive car or a robo. You consider, so that is AI. Agent means AI. So you can consider machine or anything. Okay, so environment, that is a surrounding like that. Okay, so first I will tell about what is intelligent agent. See the diagrams in this diagram. So this is a totally it is the agent like that. So this is the agent, this is the environment. Okay, that is a perceive, that is here will be say that the environment. So that is a perceive, it is environment through the sensor. So they are given to the sensor to that agent, because of in the agent means robo. Okay, in this robo they are fixed the sensor. The sensor will be, so the environment will watch to that agent, or agent will be scanned to that environment. Okay, that is prospect. Then there will be activated. So what you want to the environment, so that thinking will be do that agent. Okay, so that is called as the intelligent agent. Okay, then see now the example of the agent. So in this field of we can using that AI. First, you think human is a agent. Suppose I am a agent. Okay, what are you thinking? What is our sensor? Our sensor will be my eyes, my ear, then etc. Then accelerator. Accelerator means my hand and my legs. So let that and all. Okay, so same like that in the agent in the robotic. In this robotic, what is that? So in the robotic sensor, cameras, infrared, so like that. Some other sensors. So we can using that robot agent. Then actuators, so using the brake, motors, so like that. Suppose you can consider as a software as a agent. So in this field, we can using that keyboard, then file content. So these are all the sensor. Okay, then actuator. So we can using the monitor, printer, that is a robotic arm. So these are all actuator. Okay. So now I will show about an example you can easily understand. See, this is the example, that is a AI example. So this is a vacuum cleaner agent. Okay. So you know that vacuum cleaner means just a room cleaner machine. Okay. So with the concept, I'm using that AI. So what is your goal? To clean up the whole area. Okay. So I will fix, this is a 1 square area, this is a another square area. So that is the environment. So now you go to the diagram. So in this diagrams, environment and action. So how do they to take it? Okay. So next perspective. What is the perspective? So in this perspective, I will select the location. Maybe this will be the vacuum cleaner. They will be moved for left hand side or right hand side. If you are move the left hand side, any dirty will be there, you can clean it. So if your right hand side will be moved, you can clean it. If you are nothing will be there, don't clean that and all. Okay, that is the procedure. So we have given the instruction. So that is the action. The action will be the left, right, then sir, no operation like that. Okay, so what are the prospect, then action? Suppose in first square A, if we clean, so there the action will be the right. If you are not clean, A will be dirty. So in this time, there will be sub. So like that in the B. So B is cleaner, no problem. That is left. Or else B will be sub like that. Okay, so this is here, you are given the instruction to the machines. So the machine will be doing like that. Okay. So this is a rational agent. So the rational agent means you are given the right things, right instructions. Okay, so in this case, we can give to the rational agents. The rational agents is one of that does the right thing. It is maximize the performance measure. Okay, so how do we can fix the measure? So like that, the first one, that is a performance measure of the success agent, prior knowledge of the environment, action agent can perform, then agent perspective sequence. So I will tell about each and every point. In the 4th point, I will explain here. So this is the main important BEIs. What is BEI? First one, performance, environment, accelerator, sensor. I will given the example. You can easily what is actually performance measure. Same, I will take the example is vacuum cleaner. In this vacuum cleaner, first performance measure. What is the first performance measure? In the first performance measure, in the vacuum cleaner, maybe cleaners, time taken in cleaning, battery life, then number of movements, so maybe left to right, so that and all. Okay. Next, environment. So which you can use. So that is your room, table, floor, etc. Okay. Next, accelerator. So accelerator means we are using that wheel, different pressures, then vacuum, etc. Accelerator. So like that. So where we can using the sensor with the help of that camera, 30 direction sensor, that is a cliff sensor, pump sensor, infrared well sensor. So like that, many sensor also you have to fix it. So these are all the different category. So the different category we can using that in the vacuum cleaner. So that is called as a PEAS. Okay. Okay, so in the agent, no, in this agent, some different types will be there. So this is here 5 types. First one is here simple reflex agent, model-based reflex agent, goal-based agent, utility-based agent, learning agent. First, I will discuss about the simple reflex agent. What is simple reflex agent? Simple reflex agent means the word itself says that it is simple one. That is very short, that is a start. That is only one state. So only one state means if you can travel to the car, you have to given the in front of any speed brake will be there or any signal will be there. You are given the instruction stop or go. You are given one instruction that will be followed. Next time you give the next instruction. So like that. That's why here will be say that the simple reflex agent. Thus choose action only based on the current situation, ignoring this history of the prescription. So no history. So what is current? If you current only, they will be working. If you are eating, na eat. That's it. Don't think about remaining things. Only whatever given the instruction that only follow. Okay. The next step, perform action only in simple situations. So it is also called as a fully observable. What is fully observable? Fully observable means full state, only single state. One single state means stop na stop, start na start. So that is one full state. So that is a fully observable of the simple reflex agent. Then in the fully observable state, if you are getting one state, this is a one state. In this state, if you are moving left hand side or right hand side, you directly should not move the left hand side, right hand side. You are giving, you can apply some rules. Some rules. That rule will be conditional action. What are the rules? Suppose you are buying any car, the car also automatical program will be doing like that. So this much of so there will be program it, no? So for example, in your car, so totally 10 liter petrol will be there or diesel will be there. So if your speed breaker will be there will be given some instructions. So like that. So some rules already will be framed that will be followed, not extra rule. If any rule will be there, that rule will be followed. Okay, that's why here will be given the examples. If car will be front, the brake will be off like that. So only one instruction brake. So the front will be move, brake will be applied. So back will be come, so the brake will be applied. So like that, you are given small instructions. See the diagrams. So consider us this is a agent. So this is the environment. So you consider us this is a robot. Okay, or else this is a self-drive car. This is the environment. So in this environment, act as that this. So I will say about only current scenario, current state. What is the current state? How is world now? So what is now? So given the scenario, there will be acting then in this. So how to this act will be coming? You are given some rules and regulation that will be followed. Then there will be acting as the environment. Okay, this is a simply reflex agent. Second, model-based reflex agent. So in the model-based reflex agent, so it is like that the simple reflex agent, but here prior history will be there. So this is the starting, this is the ending, the source, this is the destination. One time the car will be travel. The next time the same car will be come this side. So previously, suppose here one signal will be there, the late of 5 hours now. The next time coming to the car, there will be informing, previously there will be informing the particular people. If you go this way, here will be traffic will be there, go some other way. So like that, there will be saying. Because previously they are experienced, one time will be reached, no? So the experience will be stored. So how do there will be stored? Same that here will be one important thing, it is partially observable. So once this will be reached, you should not reach full state. Only half state only reached. When you can reach the full, so based on this two technique there will be applied. So the two technique means once there will be reached, next time will be coming, no? So that time getting some knowledge and a history. So that is the two. First one is a knowledge, second one is a past experience. The both will be getting, then only again there will be travel. So that is a model-based reflex agent. Okay. See this diagram you can easily understand. So this is the agent, this is the environment. So in this environment, so here I cannot give the single state. In the single state, given some ideas. Some idea means this is not a whole state. In this whole state, I will given some ideas. So what are those ideas? Maybe this the single state I will give how the world will be changed. What my action do like that. So I will given the some instruction, then only there will be follow here. So directly this is also should not run. There will be apply for some rules and regulations. So previously we are given the simple reflex reagents, that is also here will be followed. That rules also will follow, then this also will be followed, then will be act. So that is called as a model-based reflex reagent. The next goal-based reagent. So goal-based reagent means, so this is a very interesting one. So the same like that in the previous one. So there will be travel here. So the car will be travel one time. The next time here, this is one place, this is one place. I will write here. So this one state. This is one state, this is another state. I will travel here. This distance will be the 5 kilometers. This distance will be the 10 kilometers. Maybe this will be traveled to here. Okay, this will be 2 kilometers. Okay, now this is a source, this is a destination. Okay, in the destinations, maybe this goal state means this will be travel yes to maybe. And this will be travel to yes to the here, that is the starting ending, the here will be travel, distance will be the 5, or else you can reach this and this. So here will be the 10 kilometers, here will be the 2 kilometers, that is 12 kilometers. Anyway, finally you can reach the goal, so that is a goal-based agent. Anyway, many ways you have to travel it. So that is called as a goal-based agent. That will be say that here. They choose their action in order to achieve the goal. So anyway, we will find it, they reach the goal. This allows the agent a way of choosing among multiple possibilities, selecting the one which reach a goal state. They as usual require research and planning. So this is also, there will be planning it. Okay, so that's why here given the example is a GPS. Okay, a GPS system finding the path of certain destinations. Okay, so this is called as the goal-based agents. See the diagrams. So here also the current state, it is also partially observable. They are given some conditions. So here will be given that goal. So in this goal means many path. The many path you can reach the goal. After that you can apply the some condition, there will be reached. Next, utility-based agent. What is utility-based agent? It is same like that goal-based agent. Listen it now very carefully. Now this is also path. This path is a 5 kilometers. This path is a 5 kilometers. Here will be the 2. Okay. This is a source. This is a destination, goal node. Okay. Now I will reach the goal. So this path, that is a goal-based agent. 5 plus 2, 7. 1 will be reached, again 5. So you are getting 2. Anyway, 2 will be the goal. Anyway, you can reach it. But utility-based agent, you compare to both, which one is a minimum. So here will be the 7, here will be the 5. 5 is a minimum, no? So the minimum path will be selected. So that is best solutions. We are getting the optimum based agent means you are getting the best solutions. So that is best way they will be finding. So that is called as a utility-based agent. But the previous one goal node means many path will be there, you can travel anyways. But finally you can reach the goal. But utility-based, so they have to fix the correct goal. That is the optimum path. That's why you will be say a utility-based agent is an agent that act based not only on what the goal is, but the best way. Okay, best way to reach the. Okay, so same like that. That is GPS. So in the GPS, say that GPS system finding the shortest and fastest safe to the sometimes the everything will be prior history also here will be stored. So safely there will be travel, this kind of instruction will be given. So if you are travel this way, you can travel to very quick manner. So like that, they are given some instructions. Because of they are getting the past experience already stored the machine, there will be given some suggestions like that. So it is called as a utility-based agent. I hope all of you understand that. So see the diagrams. So the same like that. So this is the main state. In the main state, they are given some instructions. So after that, they will be doing the goal. Many path will be find. So maybe here will be find the 3 path. Among the 3 path, we will find it one. That is happy journey like that. So it is a happy. How happy I will be that state. So okay, one will be selected. We use the utility functions. Okay. After that, you can apply some rules and regulation. Then when there will be travel. Okay. The last one, learning agents. So the learning agents, it is mostly past history, and you are given some judges and some feedback, everything they will be using here. Okay, that is, it is a very intelligent to that machine, a human intelligent to the machine. Okay, so that's why we can using that learning agents. First, read the definition. Learning agents is AI in the type of agents which is can learn from the past history or is learning capability. Okay, so there will be four components. Four components. First one, performance element, learning element, critic, then problem generated. So actually what had happened, see the diagrams. So here also we can using directly sensor. First critic, what is critic? What is critic? And learning element, what is generator? See, if your performance elements means you are getting select external action, take it perspective and decide the action. Learning element means it is responsible for making improve by the observing the performance. That is critic means feedback. So if one time there will be reached the goal. So after that they are given some feedback. So it is if you are go for this side, something will be there. So like that, they are given some feedback that will be given a critic. That is here, learn, take feedback from which describe how will be the agent is doing with respect to the fixed performance standard. Last one, problem generator. In the problem generator, they are given some adjacents. Adjacents means if you reach the goal, so suppose any difficulty will be there, they are given some adjacents. So you don't go for this way, some traffic will be there. So you go different way. So like that, they're given the instruction. I think you know that the Google map. If you are go the Google map, there are some given some instruction also. So that is called as the learning agents. Okay. So like that, there will be given. So feedback, learning goals, everything there will be given. After that, performance will be given. Finally, there will be active. Okay, so this is a type of agents. I hope all of you understand that. Anyway, finally, I will share that PDF in your ma'am. If you want, you can read it, okay? So the next category, problem solving agents. So in the problem solving agents, very important to the AI because of if you are creating, this is a machine, we don't know anything in the machine. You have to train, no? In this train, how you can train it? First skill, you can give the problem solving technique. Okay, so how do you can give the problem solving technique? So we many method you have to apply. Okay, just I will discuss about few method only. Then I will move to the next topic. Okay, see the definition of that this one, that is relational agent or problem solving agents. In AI mostly use this searching strategy or algorithm to solve the specific problem and provide the best result. Then problem solving agents or goal based agent and use atomic representation. What is this? I will tell about here. Some technology. This is a some terminology. Some terminology using that AI. I hope you know already we are study for the data structure. All the data structure is a very important subject. All the data structure here will be applied for the AI. Okay. So first concept will be the search. You know that searching concept, maybe binary search or AVL tree, whatever it may be, meaning the display tree, many tree will be there. So here will be using searching concept also here will be applied in the AI. Okay. So then next is start state, goal state, that is a initial state and goal state like that. The next action means just one state to the next state will be the move. So these are some terminology. Next transition model. Transition model is the path. This path, how to there will be travel. Maybe the distance will be 5. That is a path cast. That is a 5 is a path cast. The path, the arrow mark, no. So that is a transition mode. Next is solution. If your source to destination reach, the solution will be the 5. Optimum means if you are giving the many path, one path will be the getting the good solution. So that is what is so optimum. Then I will show about one example for problem solving. I already know that this is the best example for the AI water jet problems. Just I will discuss, just you can watch it this. So 4 Kellan and 3 Kellan check I will take. So this is a 4 Kellan check. This is a 3 Kellan check. Okay, very interesting one. Just you can watch it. So here, actually, what is a procedure? You don't mark anything. That's why here we see the first rule. No measure mark on the jack. There is a pump to fill the junk with the water. That how can you get exactly 2 Kellan of your water into the 4 Kellan check? You know that the main question is, this is a 4 Kellan check, exactly how to fill the 2. This is a 4 Kellan, exactly I need the 2 liter. So the 3 liter jug will be the empty. So this is a goal. So initial will be the 0, 0. Okay. So this is, they are given the question 4 jug. So here will fill to 4, here will be the 3. So how do we can reduce? So how to, you can swap it the values. Okay. See this, some representation. So here X representation of the quantity for your water in the 4 Kellan jug. So you know 4 liter means the what are the possibilities will be there? 0 liter or 1 liter, 2 liter, 3 liter, 4 liter. So totally 4, because of maximum capacity will be the 4. Like that, Y will be represent the second jug. The second jug, there is a 3 Kellan jug. So the possibilities is 0, 1, 2, 3, 4. Okay. Now we'll find the 2 state. One is a initial state, one is a final state. You know that initial state means this is a initial state. What is a final state? The question itself say that. What question? How can we get exactly 2 Kellan of your water into the 4 Kellan jug? This now. So this is a goal. Okay. Now, so this is a rule. So this rule you have to apply. First empty of the jug. Okay. Next fill the water. Next pour water from one jug to the another jug. Maybe you can transfer to here or you can transfer to here. This is a procedure. Can you audible? Anyone replace or no? Yes. Can you audible? Yes.
Yes, sir, you're audible, sir.
Okay. So these are the some protection rule. So suppose this is a initially xy means that is a x Kellan, y Kellan like that. I will given the condition if x less than 4, then y less than 4. Suppose x less than 4 now, how to that jug will be there? Fill the 4 Kellan jug completely. Suppose y less than 3 now, fill the 3 Kellan jug completely. Suppose x greater than 0 now, so the x will be modified. So some liter water will be taken, no? That was pour water from the 4 Kellan jug. So like that in the y, like that in the x, like that in the y. Okay. Now we'll solve the problems. This is interesting. So how do there will be transfer to that problem? So first I will take the empty because of this is called as a initial state. Okay. Now I will fill all 4 liter water here. Okay. Now x will be the 4, y will be the empty. Okay, now in the 4 liter water, I will put it here. Okay, because next step. Now you know that this is a 3 liter, no? Now the 3 liter will be filled. Now here 1 will be the empty. Okay, the next step, the 3 liter entirely I take out. So this will be the empty. You having only for 1 liter water. Next category, this 1 liter water transfer to that 3 liter jug. So here will be changed the 1 liter. Now this will be the empty. Okay. Now again I coming to that. I will fill the 4 liter. Then already you having this 1 liter. Only I fill 4 liter jug only. Okay. Now this is a 4 liter. This is a 1 liter. Now again this 4 liter water here will be filled. Already 1 liter will be there. Now we'll fill the 2 liter. Totally this is a 3 liter. This is a 2 liter now. Now the 3 liter water take outside. So what is the remaining? Only 2. So what is your goal? 2 and that is a 4 Kellan jug. We have to fill for the 2 liter. the 3-liter jug only for the empty. Now you are achieving the goal. So like that, you can practice with the system. Okay. Then searching algorithms. Before that, searching algorithms will go. Just I will play one videos. Then I will come to that concept. Okay. Can I play the video? Yes. Wait, I will play the video.
Powerful examples of artificial intelligence. If you looked up the term artificial intelligence, found used AI. If you've ever taken an Uber or had your phone autocorrect a misspelled word, you've used AI. Although it may not always be immediately obvious, artificial intelligence impacts nearly all aspects of our lives in a nearly uncountable number of ways. In this video, we'll take a look at 10 examples of how artificial intelligence saves us time, money, and energy in our everyday life. 1. Maps and navigation. AI has drastically improved traveling. Instead of having to rely on printed maps or directions, you can now use Waze or Google or Apple Maps on your phone and type in your destination. So how does the application know where to go? And what's more, the optimal route barriers, and traffic congestions. Not too long ago, only satellite-based GPS was available, but now artificial intelligence is being incorporated to give users a much more enhanced experience. It makes our ride easier as it suggests to us about the traffic, distance left, and voice suggestion of the route. 2. Smart cars. Autonomous vehicles are prime examples of how artificial intelligence is impacting the automotive industry. A large segment of autonomous vehicles are connected and thus able to share the learning with each other. This percentage is set to increase rapidly in the future. Smart cars are one of the areas where AI is increasing its importance. Not only big companies like Tesla, but many of the other companies are using automation in their vehicles. Artificial intelligence implements computer vision, image detection, and deep learning to build cars that can automatically detect objects and drive around without human intervention. 3. Text editors or autocorrect. AI algorithms use machine learning, deep learning, and natural language processing to identify incorrect usage of language and suggest corrections in word processors, texting apps, and every other written medium, it seems. Linguists and computer scientists work together to teach machines grammar, just like you were taught at school. The algorithms are taught through high-quality language data, so when you use a comma incorrectly, the editor will catch it. 4. Facial detection and recognition. Using virtual filters on our faces when taking pictures and using Face ID for unlocking our phones are two examples of artificial intelligence that are now part of our daily lives. The former incorporates face detection, meaning any human face is identified. The latter uses face recognition, through which a specific face is recognized. Facial recognition is also used for surveillance and security by government facilities and at airports. 5. Smartphones. Now also you are using your smartphone while watching this video. There is no need to tell you the importance of smartphones in our lifestyle, as everyone is aware of the fact that we cannot imagine our lives without smartphones. Whether you know or not, you are interacting with AI. We know that Google Assistant, Siri are all examples of AI in our phone. But not everyone knows that portrait mode in the camera is also based on artificial intelligence. There are many more features in our smartphones that use AI, and in the coming future, we will see many more features because of artificial intelligence. 6. Smart home devices. Rise of AI has exceptionally solidified the term smart home. A significant number of smart home devices that you buy use AI to learn your behavior so that they can adjust their settings automatically to make your experience as frictionless as possible. These smart home devices are controlled by using smart voice assistants, which are prime examples of AI. These techniques are part of our lives thanks to data science. While it's true that it'll take a significant time for us to see a perfect AI-powered home capable of reacting to our choices in real lives, steps are already being made to bring this to the real world. Already, there are smart lights that can change intensity and color based on time and thermostats that can adjust the temperature based on user preference. 7. Social media. If you're thinking that emergence of autonomous vehicles isn't having any impact on you personally as they're not in your city yet, how about something without using which your day doesn't end? Yes, we're talking about social media. If Facebook isn't your thing, maybe it's Twitter or Snapchat or Instagram or any of the other available social media apps. The fact is, when you're using social media, a majority of your decisions are being influenced by artificial intelligence. From notifications that you receive to feeds that you see in the timeline, everything is curated by AI. It considers all your past web searches, interactions, behaviors, and everything else done by you during your visit to these websites, and tailors your experience according to that. 8. Chatbots. As a customer, interacting with customer service can be time-consuming and stressful. For companies, it's an inefficient department that is typically expensive and hard to manage. One increasingly popular artificially intelligent solution to this is the use of AI chatbots. The programmed algorithms enable machines to answer frequently asked questions, take and track orders, and direct calls. Chatbots are taught to impersonate the conversational styles of
Excuse me, sir.
Yes.
Sir, the audio is not audible, sir.
Okay, I think that some of the students say that audio not coming. Okay, I will share the link. You have to watch it. So these are all the technique nowadays that is a current trend. So this will be using that AI. Okay, I'm going to that PPT because of only half an hour time which there. I will fastly I will explain. So again, I'll come to that searching algorithm concept. So these are all the concept you have to apply that AI. This is a very important thing. I already told you the data structure is a very important because of here all the data structure concept here will be applied. Because of what are the data structure you can using that tree, graph, and then stack, queue, that and all you have to apply here. Okay. So in the searching we have two technique. One is a informed search, another one is a uninformed search. So in the uninformed search, another name is a blind search. So that is a informed search, and another name is a heuristic search algorithms. Okay. So what is uninformed search? The uninformed search means you should not give any additional information. So what they are having the information, that information only they are only following. But in informed search algorithm, you are giving some additional information. For example, your name and your age, so like that. You are giving some additional. So that is called as a informed search. Okay. So that is the uninformed search. There are different types of uninformed search will be there. First one is a breadth first search, uniform cost search, depth first search, depth limited search, that the next iterative, deep in depth first search, this bidirectional search. Okay, first I will discuss about that. This is already say that is a you should not give any additional information. Okay. So first I will discuss about the breadth first search. You know that already we are studying that data searcher, same concept only here will be applied. So with you know that in the breadth first we can using the concept will be the queue. Okay, the queue principle is first in first out. Okay, so what is there that in the definition in the here will be using any graph or tree. Okay, that's why here will be say that breadth first search is the most commonly searched strategy for traverse to tree or graph. This algorithm search breadth-wise in the tree or graph, so it is called as a breadth-first search. The BFS algorithm starts search from root node of the tree and extend all successor node at the current level before moving to the node to extract. That is the next level. Okay, it is using the concept of will be the FIF. See the example, you can easily understand. Okay. So now in the breadth first concept, so how do we can apply to the AI? So see, this is a source node, this is a goal node. Okay, this is a starting, this is a goal node. How do there will be travel? So these are all categories. This is a level 0, level 1, level 2, level 3, level 4. The breadth first means we'll go for the level by level. So yes, will be started. Next we can visit the A node. Then next visit the B node. Next we can visit the C node. Then D node, G node, H node, E node, F node, I node, then K node. Okay, so this way you can travel to the breadth first search. Okay, maybe you are studying the data structure also, we are using that table. Okay, the three table we can using, that is a first one is a visitor node, unvisited node, then using the queue operations like that. Okay, so after that here will be visible, yes will be visible, yes will be right like that. Same concept here will be using, but we can using here directly I will solve the answer. Okay, just this will be visit first, S will be visit, next A will be visit, B will be visit. So you go for level by level. So that is called as main concept of the breadth first search. Okay, you directly don't find in the K. S to K should not come. Only level by level. All the level will be completed, then will be find the goal node. Suppose your goal node will be the H na, so you can travel A to B, B to S to A to B, B to C, C to D, D to G, G to H. Okay, so this is a goal node. The next, so these are some advantage of the breadth first search. The BFS will provide a solution if any solution exists. If there are more than one solution for the given problem, then BFS will be provide the minimal solution which is required to a last number of steps. Okay. The next, some drawback also is there. It requires lot of memory since each level of the tree must be saved into memory to extend the next level. Okay, the BFS need to lot of time of the solution in far away from the root node. The next concept is here breadth first search. In the breadth first concept, we can using the stack concept. Okay, stack means you know that is a last in first out. Using that concept is be the last in first out. Okay, this concept we can support it to the this. So how do there will be travel? That is also will show the example, we can easily understand. See here, so this is a G is a goal node. Okay, how do there will be travel? Even the BFS, you can travel this A to B, B to H like that. Okay, but in the depth first search, we go for very depth manner because of using the stack. No, that is last in first out. So there will be travel to the A. The A will be depth to the B. B will be depth to the D. Then we'll go for the E. Then we'll go for the C. Then you'll go for the G. So now your goal will be reached. Suppose I am using the goal node will be the J. What we are doing? So again, S will be travel to here. Next, this will be travel to here. This will be travel to here. Next, this will be travel to here. This will be travel to here. This will be travel to here. The next will go for here H. The next in depth, that is I. The next again K. Then only you can reach the goal will be the J. Okay, so this is a depth first search. So this is also some advantage, disadvantage will be there. The advantage is here, DFS require very less memory as it only needs to store stack of the nodes and the path from root node to the current node. It will take less time, okay, to reach to the goal node BFS algorithms. Some drawback also is there. There is the possibility that may state keep occurring, and there is a no guarantee to finding the solution. So sometimes you're not getting the solutions. So sometimes in the infinite loop also some problem will be there. That is a drawback. See the next step, depth limited search algorithms. So depth limited algorithm, it is also using that stack concept. Okay. Stack concept. In stack concept means you know that last in first out. The same, but here some conditions. Okay. What is the conditions? So the two conditions. One is standard failure value, another one is a cutoff failure value. What is standard failure value? It indicates that problem does not have any solution. You are not getting any solutions. That is the standard failure values. Next, cutoff failure value means it defines no solution for the problem within the given depth limit. What is actually there will be say? See the example, you can easily understand. Now, the depth limit means I will fix level will be the 2. Because of I will fix it. The level will be 2. Okay, so goal node will be J now. You know that depth means there will be travel A to B, B to, that is S to A to C. Okay, in depth manner you have to travel now because of it is using the DFS concept. DFS means depth. So S to A to C, C to E will be travel, but you are given the limit is level 2. So this will be the removed. Okay, so that's why there will be travel here. Again, this will be finished because of you are completing the second level now. So this will be the over because of goal node will be here. So again, there will be travel here. In depth, there will be coming. So this will be remove it because of level will be the 2. So final reach the goal. Okay, the same question. Level will be the 2. The goal node will be the H. How do you find the answer? Now, that is a drawback. Now, well, goal node will be the H. Okay, but I will say the level will be the 2. So how do there will be fine? Here will be fine. Here will be fine. The level 2 will be the over. Okay, but your goal node will be, that is level 3. But your limit will be 2, no? So should not find. You are not getting the solutions. So that's why previously say the failures. I hope all of you understand that now. Okay, the limit will be fixed. So here also some advantage, disadvantage will be there. The memory will be efficiency, but that optimal solution should not get because of the goal node should not reach it. Sometimes only you can get it the goal node. Sometimes should not get the goal node. Okay. The next step, uniform cost search algorithms. So that is a uniform cost search algorithms. So the same like that in the DFS and BFS, but here given that weight. Okay, I will show the example. I cannot read the theory that I have. I fastly move. Here will be using the priority queue. Whatever it may be, you can using the concept, but using the cost. Okay, given the priority queue. So here the A will be A to B, A to C. Okay, now path A to B path, the weight will be the 1. A to C path will be the 5. So which one is a minimum path? 1 will be minimum path, there will be travel. That is uniform cost. Next, consider as this is a source. Here will be 2 node will be there. Here will be the 5, here will be the 3. Which one is a minimum? 3, here will be travel. Next, consider this. So now there will be only one path, there will be reached. G is a goal. Okay, so this is a uniform cost search. See, this is the example also the same. So here compared to here will be the 4, here will be the 1, here will be the 4. Here also goal node will be there. Here also goal node will be there. Here also goal node will be there. So you check the cost. You have to check because of uniform cost. So you check the cost. Here will be 1. Here will be 4. Minimum distance. Here will be travel. Next here will be 3. Here will be 2. Yes, this is a minimum. Here we will compare. Here will be 3. Here will be 5. Here will be 3. So 3 will be minimum. There will be travel. The path will be travel S to A to D, D to G. The goal will be reached. That is uniform cost. So here also some advantage will be there. So in this advantage, you have to find the optimal solutions like that. Okay. So here also we can some drawback will be there. So sometimes the infinite loop will be getting like that. The next iterative depending depth first search algorithm or else iterative deepening depth first search algorithms. So the meaning is we can using DFS or BFS, whatever it may be, but you can using the iterative. So the iterative or iterative. So I will directly go to that example. So this is there is a depth level 0, this is a depth level 1, this is a depth level 2. So using the any concept, DFS or BFS. So suppose I'm using the DFS. DFS means first level, that is 0th level, A only find out. Okay. Suppose the goal node will be F now. So first A will be travel, you should not get the goal. Next depth now. So second level. So level by level will come. Okay. Second level A, B. That is this level now. A, B, C. So again you should not getting the goal. Next goal will be here now. How do you can find A, B? You go to the DFS. Okay. A, B, D, E, C, F. So now you are getting the goal node. Okay. See one more example you can easily understand now. Here goal node will be the G. How do we find the iterative? This is the iterative 1, this is the iterative 2, this is the iterative 3 like that. So first iterative you should not get the goal. Second iterative A, B, C should not getting the goal. Third iterative A, B. So how do you can find? A depth manner you can go. Okay. A, B, D, E, C, F, G. Okay. Now you can get the goal. So one more possibility also will be there. Check again depth A, B, D, H, I, E, C, F, K, O. That is one more possibilities. So you are getting 2 goals. So that is same. You have a different way you have to find it. So that is a iteration process. Okay. Last one, bidirectional searching algorithms. So in the bidirectional searching algorithms, so here also we can using any DFS, BFS. We are using here new concept is here forward search and backward search. So this is your bidirectional graph. Okay. In this graph, I can divide it 2 parts. So this is a one part. This is a another part. Okay. So in this part, here will be apply. This is a forward approach. This is a backward approach. In the forward approach, I will fix. This is a initial state. This is a goal state. Here will be take. This is a initial state. This is a goal state. Now you are getting 2 graphs. Separately, you can derive split to the 2 graphs. Now in this graph, you can apply the DFS concept. This graph, you can apply the DFS concept. Okay. Now you are getting one solution. Okay. So that is called as a bidirectional search. I'll repeat again. Entire graph you can divide 2 parts. 1 minute. Entire graph you can divide 2. 1 minute. Screen will be something. Yeah. So now, so 2 part you will get it. This is a one part. This is another part. This part you can apply the DFS algorithm. This is also you can apply the DFS algorithm. So now you can merge it. So that is called as a bidirectional search. So here also some advantage and disadvantage will be there. The next search, that is a informed search. I already told you that is a informed search in the sense you are given some additional information. Okay. The additional information means that is heuristic value. That is additional information. You are giving the heuristic values. What is heuristic value? Here A to B given the cost. Okay. A to C given the cost is 3. Okay. This is general graph. That is a uninformed search. But here in the heuristic means you check A to C given one additional information to the 10. B, one additional information is there 12. D, some additional information is 11. So that is heuristic. Heuristic means some additional information. Okay. So in this additional information, how do we can solve it the problems? So we will go for the two ways. Many ways it is there, but I will do about only the two important algorithm only I will explain. First one is a best first search algorithm. Second one is a star search algorithms. Okay. What is best first search algorithms? So the best first search algorithms, we will find the shortest path with the help of the heuristic value. I show the example directly. This is a graph, okay? This is a graph. This is a heuristic value. That is the additional information. What is the additional information? That is, yes, additional information is 13. B, additional information is 4. A, additional information is 12. Okay. So now this is a source node, this is a goal node. How do we can reach the goal? Okay, how do we find it? Okay, I will check. Check now. Normally you go for uninformed search, S to A, B, the shortest distance 2 will be fine. Okay, the next, this is consider, this will be compared, this is a small distance, we can compare. Again, this will be compared, this is a small distance, we will travel here. Okay, so this is a uninformed search. So here we'll be using the best first search, so how do we find it? Check now. S value is 13. Okay, no problem. Now you compare to heuristic value, not for the cost. Okay. Now, what is a heuristic value? A heuristic value is 12. Okay. What is a B heuristic value? 4. Now, here 12, here 4. Which one is a minimum? 4 is a minimum. We can travel. Okay. Next, we are in here. Don't consider for the cost. Okay. Now here. E, what is the E value? E value will be the 8. F value will be the 2. Which one is a minimum? 2. There will be travel here. Okay, now F will be considered I value. I value will be 9. G value will be the goal. Goal node always code as the 0. I will check. Here will be the cost will be the 9. Here will be 0. There will be travel. So you reach the goal. So what is the cost? This don't add 4 plus 2. This is a heuristic value. What is the cost? 2 plus 1 plus 3. The value will be the 5, 6. Total cost will be the 6. But a heuristic total cost will be 6. Almost here will be same, but this is not count. Because of problem will be different. No? So not getting correct answer. Okay. You find only the cost. Total cost, no, this. The total heuristic value, that is a different. Okay. So that is the answer. So these are some advantage, disadvantage will be there. Next one, A star search algorithms. In the A star algorithm, it is like that the data structure shortest path algorithms. So mainly using this formula, f of n is equal to g of n plus h of n. Okay. So the f of n, that is the estimate cost of the cheapest solution of the f of n, that is the minimum solutions. Okay. Next, g of n, then h of n. What is g of n? Cost to reach node n from this state, that is your start state. That is start state. Okay. Next, cost reach from node n node the goal node. So only you can remember the formula. So this is a problem. So this is a graph. This is a heuristic value. Okay. So how do you can solve it? See this in this graph. This is a graph. This is a heuristic value using this formula. Okay. In this formula, I will travel. That is S to A. So how do we can find? So g of n plus h of n. So g of n means this value. Okay. H of n means A heuristic value. Okay. Now you can travel S to A. The distance will be the 1. The A heuristic value will be the 3. Okay. That 3 will be. That is 1 plus 3. The value will be the 4. First will be travel. Okay. How do we can reach the goal? Okay. So first step will be the second S to G. The cost will be the, that is g of n will be the 10. G will be the 0. So the cost will be the 10. Next A to S to A to B. S to A to B. Check now. The cost here 1, here will be the 2. 1 plus 2, 3. S3. Which one will be reached? B, no? What is the B heuristic value? 4. That is 3 plus 4, 7. Okay. So same like that. SAC. That is SAC. 1 plus 1, 2. C heuristic value is 2. The total value will be the 4. Like that, SABD, like that. All the value you can find it. So finally you can get it S A C G. Check G is a gold node, no? G is a gold node, but you are getting the cost will be the 6. Here also G, yes, direct path will be there, cost will be the 10. Which one is a minimum? So this is a minimum. This is you are getting the minimum cost and optimal solution of the A-star algorithms. Okay. So this is also some advantage, disadvantage will be there. Next to local search algorithms. In the local search algorithms, so just I will tell about the concept. Just you will find it the nearby node. So this is 5 now. Next you will find for 5.1. Nearest node. Nearest node only you can find. Okay. So that is a local search algorithms. Here some many games they are using that AI concept. So here I show about only one examples. That is a 8 buses algorithms. So in the 8 buses algorithms, so this is a initial state, this is a goal node. How do you can solve it? You know that in the game. So how do you can move the left movement, right movement? So finally you can get the solutions. Okay. So this is the your given question. I will move left and this is the left movement, then up movement, down movement, right movement. Okay. So all the movement will be over. After next step, how do I find it? Just you check. First you will find the heuristic value. How do you find it? So you know this is a goal node. I need this is a final solution. How do you can get it? Check. Here will be the 1. Here will be the 1. No problem. Here will be the 2. Here will be the 2. No problem. Here will be the 3. Here will be the 3. No problem. Here will be the empty. Here will be the 4. That is also don't consider. Here will be the 4. Here will be the 5. Different. So I will write 1. Okay. Next here will be the 5. Here will be the 6. That is different. So again 1 will be right. Next we'll check. Here will be the 7. Here will be the 7. Same. Limit it. Here 8. Here 8. Same. With it. Here 6. Here empty. But here number. Here will be empty. You can consider. Now you are getting again 1. Totally 3. Now this total table heuristic value will be the 3. Like that, this and this will be checked. You are getting 3. Like that, this will be checked. This will be checked. Your heuristic value will be 3. Like that, this table and this table will be checked. Your heuristic value will be 1. Check among the 4 which one is a minimum. So this is a 1. Now we are in here. Next again we can divide. Okay. Again left movement, up movement, down movement. You can do it. Now again this will be checked. This will be checked to the this one. This one check. The goal node no. Again we will check. So now we'll check which one is a heuristic value less. The heuristic value 2, this heuristic value 2, this heuristic value 0. Now in the 0th value check, this value same, you will achieve the goal. Okay. So the next consent satisfaction problem, some condition will be given. So that is a crypto arithmetic like that. So what is the rules? So based ball, you are getting answer will be the game. So this is our brain will be thinking. So each and every letter you can using unique letters. For A you are using the 1 now, all the A you can using the 1. Okay, L value you can using 2 now, all the L value 2. But total everything will be same like that you can get it. So, okay, some rules also will be there. So these are the rules. That is a crypto arithmetic. Okay, 0 to 9 number will take it. So how do you can fill it? So like that. So this is the question. This is the answer like that. So this is a min-max game. I'm going to that many concept will be there and yes, last minutes. So I'll come to that only one concept, machine learning. Just 2 minutes. So in the machine learning means the machine automatically will be learning. Okay. In future, the machine learning use data to detect the various patterns to given the data set. Okay, it can learn from the past data and improve the automatically. Okay, so machine learning, that 3 types of machine learning will be there. One is a supervisor learning, unsupervised learning, then one is a reinforcement learning. Okay, that is supervisor learning means they are given some labels. Okay, unsupervised learning na should not give any labels. The reinforcement learning na, so there will be getting self-learning. Okay, so that is we can use in the reinforcement. Okay, so like that we can using. So nowadays we are all the places we can using that machine learning. Okay. So this is the main thing, supervisor learning and supervisor learning. So just machine means did not do anything. So there you have to give to that practice to the machines. See, this is a machine. The machine did not know this is a raw mango or ripe mango. Did not know. You give. Okay. Okay. Thank you all. Any doubt you can ask me. I'm complete. Hello, ma'am. Any
Hello,
queries you can
sir.
ask me. Thank you all.
Okay, sir. Thank you, sir.
Okay.
Dikshita, I request you to conclude the session.
Yes, ma'am. Thank you, sir, for your valuable time and acknowledging us with the AIML. And we all know that how AIML is playing a key role in today's development. We have learned something new from today's section. And I thank all HODs, faculty members, and my fellow friends, students for being so cooperative. Thank you all.
Thank you.